This is gonna 197, page 197. This is just gonna be like adding them, but we're subtracting them. But when we're talking about integers, we have to think about our integer rules, right? So the things that we're gonna run into now when we're subtracting are things like subtracting a negative. Remember, when we subtract a negative, we're really gonna be adding that. I'm gonna have to sharpen something. All right. Do you want to watch the animation?
Yeah.
I don't know. Could be good, could be bad. This is guys. This is lesson 4.3. So you can find it on your own too. Let me share this. Okay. This is what we want here. Are you ready? It might be kind of loud. I'm warning you now. Don't freak out.
Rational numbers.
Be quiet.
Write the numbers in the same form. One way to subtract a decimal from a mixed number is to write the mixed number as a decimal. This method works if the mixed number can be written as a terminating decimal. Next, find the difference. To subtract the decimals, rewrite the subtraction as addition and add its additive inverse. Follow the rules for adding negative decimals.
So
another way to subtract rational numbers in different forms is to write the decimal as a fraction or mixed number. Use this method when a fraction or mixed number cannot be written as a terminating decimal. If the fractions have different denominators, rewrite one or both fractions using a common denominator. To rewrite a fraction, multiply its numerator and denominator by the same number. Next, subtract the fractions or mixed numbers. Sometimes when you subtract mixed numbers, the fraction in the first mixed number is less than the fraction in the second mixed number. In this case, rename the first fraction in order to subtract. Then, rewrite the subtraction as addition and add the additive inverse.
okay, that's a lot of steps, right?
Finally, simplify the difference if necessary.
So that can be pretty overwhelming. Some of these things are going to have lots of steps, right? Let's stop sharing. All right. So on your paper here, it showed you, hold on 1 second. What are y'all doing? Elijah, get out of football. All right. Now, the animation showed this, guys, right? They could write this as a terminating decimal, so they did. It's always easier to turn it into decimals, right? Because we don't have to worry about common denominators and all that. And we can throw it in a calculator. Why are you still talking? I don't know. All right, please turn it off. The second one they had to use in fractions because 2/3 is a repeating decimal. This is page 197. So when they did this, they found that once they had common denominators, when what they were subtracting from was more. So they borrowed from the 4 here. It became 3, and since each whole is 15 parts, they added that 15 to the 9. Cameron and Nick, please be quiet. So 15 plus 9, that's where they got the 24 from. Then they were able to say 24 minus 10. This is page 197. And then 3 minus 2, which was 1. That's what they were doing there for those they walked through. Are you girls okay? All right. So remember, this is the same thing we saw from 4-2. Was that if it is terminating decimals, we can change everything to a decimal. Easy peasy. But if it's non-terminating, we have to change everything to a fraction. So we can always change things to fractions, but we cannot always change them to decimals because sometimes they repeat. All right, here's our first example. Use the same rules to subtract positive and negative decimals as subtracting integers. Remember, we have minus a negative. So I have to keep change. This is page 198. So remember, we keep change. So we're really saying -3 plus 6. That's what we're thinking about. But instead, we do have some decimals to worry about. Can you just put it into your calculator? Yes, you can just put it into your calculator. But when we have the additive inverse here, our signs are different, so we find the difference. So we're really saying 6.7 minus 3.27. We had to borrow. This is really a 0. If we borrow, 10 minus 7 is 3. 6 minus 2 is 4. 6 minus 3 is 3. So that's what they're getting the 3.43. And it's positive because our bigger number was positive. Guys, I shouldn't have to talk to you over and over. Please be quiet. All right, so because the absolute value of 6.7 is greater than the absolute value of 3.27, we just said this, the sum has the same sign as that 6.7. So it is positive 3 and 43 hundredths there. So try that check. Remember, when we're subtracting this, -4.2 plus a -3.57, our signs are the same. So you should be finding the sum. So try that one. I know, sometimes when I turn my light off, it's too dark. There, that's better. All right, so most of you figured this out. Our sum, we're adding 2/10. We still have 7 hundredths. 2/10 and 5/10 is 7/10. Our ones, we have 3 and 4 makes 7. Your answer should be -7 and 77 hundredths. Good deal? All right, here's where it gets a little trickier because we have fractions. Dun, dun, dun. In this case, 1/3 as well as the 5/9 would be repeating decimals. So we have to rewrite these as fractions. Next, they made them improper fractions. So they said 3 times 5 plus 1 is 16 over 3. 9 times 4 is 36 plus 5 is 41 over 9. Now, don't forget, this is really keep, change. So really, the lowest common denominator is 9. So this is really times 3 here. 16 times 3, if you use your times table, 16 times 3 is 48. So I have 48 ninths minus a negative 41 ninths. In this case, we're going to change, right? So it's really 48 ninths plus 41 ninths. What's 48 plus 41? 89 ninths. How many ninths can I take out of 89? 9, which is 81. So if I subtract 81, how many are remaining? 8. 9 and 8 ninths. So look, they give us the answer here. Now, they gave us a really dumb one to check. You know why this is dumb? Because we can turn this into a decimal if we wanted to. Those are terminating decimals. So you can do this either way. You can do these as a fraction, oops, or you can do these as decimals, whichever way you choose, but try that check. They should have given us something that was repeating, so we have to do it as a fraction. I need like a longer desk or something. Is that better? No, that's the problem. I'm trying to check, please. All right. So if you did this by decimal, you're probably done. If you did it by fraction, it might take a little longer. So I can think of this, change these out of 10, right? So 3 and 5/10 minus negative 1 and 3/10. So keep, change. So we're really adding these, so that shouldn't be that difficult. 3 plus 1 is 4. 5 plus 5 is 8/10. And we would have to simplify. I can divide these both by 2. So if you did it by decimal, you probably got 4.8, hopefully. And this is 4 and 4/5. All right, last example, guys. This section should be pretty quick. Evaluating expressions. On your quiz, listen up. On your quiz, you do have to evaluate expressions. That's just like when you put in what that letter equals. So I always put in parentheses. So in place of my X and Y, I would just put parentheses. And then in my parentheses, I would put what they equal. So here they put in negative 2 and 4/5 because that's what X equaled. Here they put in 1 and 4/10 because that's what Y equaled. So they added the inverse here. When your signs are the same, you find the sum, and they just added them up. If you did it using fractions, they changed to make them fifths. 4/10 can be, wait. Yes, 4/10 can be written as 2/5, so that's what they changed that to. Yes, this is page 200. Page 200. So here, X minus Y was equal to negative 21/5 or negative 4 and 1/5. So you should know how to do it by decimal. you should know how to do it by fraction. Now here we have x minus y. So I always start and I write parentheses in place of my x, then I write minus, and then I put parentheses in place of my y. Now, guys, this is important because you have to do this on the quiz. Now, in place of my x, I'm going to write this in here. In place of my y, I'm going to put this in here. So 3 3/4 is x. And careful, use the sign -4 2/10. So 4.2. Now, this is a terminating decimal, so it would probably be easier to write it as a decimal. You can say 3 divided by 4 in your calculator if you need help. Or 3/4 is the same as 3/4. How many cents are in 3/4? 75. So this is really 3 75/100 minus -4 2/10. So keep change. You're really just adding these. So you're coming up with 7 95/100. It might look a little bit different if you did them by fraction. That's okay too. So now you simply need to practice. You're going to subtract, writing in simplest form. Pay especially close attention to 13 and 14 and 15, because questions like that will be on your quiz. Questions like these other ones will be there. You don't really have to subtract negatives, but you do have to add and subtract different fractions or decimals. If you're using fractions, be sure to write in simplest form. Obviously, you can keep this as a decimal. Keep it as a decimal. Keep it as a decimal. Keep this one. You could change to decimal if that's easier. You could change to decimal. You cannot change this one. This one has to be a fraction. Fifteenths. This one has to be a fraction, I think. This one you can change to decimal. This one has to be a fraction. This one has to be a fraction. And this one probably has to be a fraction. They don't. That's only 5. So about half. A little less than half, yes. The calculators are right up here in the front. Sorry, if you can't see them, they're on the other side of the big black flag and a basket. All right, guys, page 201 is yours. You got about 20 minutes almost. Page 201. I should have written it like here. There.